Hello, my name's Diarmid Campbell and I am a Senior Software Engineer at Fetch.ai. In this video I'm going to take you through how to set up a car park agent on the Fetch.ai network. So currently one of these agents consists of a camera plugged into a Raspberry Pi running one of our programs, which is what we call an agent. And the purpose is to look out at car parking spaces and monitor how many of those spaces are available to parking. Now at the moment these agents will tell you whether there's a parking space available right now, but in the future they could include prediction models which would perhaps allow them to predict whether there's likely to be a space in, say, an hour when you're due to arrive there. In this video I'm going to cover all the steps needed to get this system up and running. So that includes putting all the hardware together, installing the software and configuring it, and also then how to control your Raspberry Pi over the network from your laptop. And everything you need to do this project is listed in the description of this video. If you note, I'm using a Raspberry Pi 4 for this video, but there are written instructions on how to get it running on the Raspberry Pi 3 as well. And finally, detailed instructions for this project can be found on our GitHub page.
So the first thing I'm going to do is put together the camera and Pi box, and I'm just going to follow the instructions on their website for this. Okay, so here's a thing. So because this camera box is designed for the Raspberry Pi 3, this bit would normally fit on like here with an HDMI socket there, but the Raspberry Pi 4 actually has two mini HDMI sockets and this bit doesn't fit in. So if I had more time I would file out this bit and make it bigger so it did fit, but I'm just going to leave it off for the time being. Okay, so I've built the thing. Now plug in monitor, mouse, keyboard. So on the Raspberry Pi 4 there are actually two mini HDMI sockets, and you should plug the HDMI cable into the one labelled HDMI 0. Before we connect the power, we're going to need to insert the SD card, which you'll find inside here. So there's an adapter and the SD card is there. So if you've got your SD card new with a Raspberry Pi, it's going to come pre-installed with the Raspberry Pi's operating system, which is called Raspbian. If you're using a different SD card, you're going to need to first format it and install something called Noobs on it, which stands for New Out-of-the-Box System. However, this one is bought new with the Raspberry Pi, so we're just going to insert it in here. Plug the power in.
Okay, so the Raspberry Pi has booted up. There's a few things to do before we start, so let's just do this, get started. So one of the first things that you'll need to do is set up your connection to your Wi-Fi. I'm actually running with a wired connection here, so I won't need to do that, but you'll need to put in your Wi-Fi password. Let's set up the keyboard. And we need to put a password in here just for the purpose of this video. I'm going to make this a very insecure password and say ABC123, ABC123. And that is fine. I don't need the Wi-Fi setup.
And I'm actually going to skip this step where it's offering me the chance to upgrade everything because we're going to do this manually using the terminal. So skip, your Raspberry Pi is now set up and ready to go. Okay, so I'm going to open up a browser because we're going to need these instructions for the car park agent quite a lot. So I'm going to get the web page up here and save it as a bookmark. So let's go to github.com/Fetch.ai/car park_agent. Okay, and if we scroll down, there's the instructions here. So I'm just going to save it as a bookmark. Bookmark this page. Done. And bookmarks, show bookmarks bar. So we've now got this up at the top here. Okay, so now we've got to this point. I've bookmarked this page. We're now going to ensure that the Raspberry Pi operating system and software is up to date. This is really important. If you don't do this, the car park agent will not work. So I've opened up a terminal. I'm going to say sudo apt update -y. Okay, and then the next line, actually it's much easier to just copy and paste these things in. So Control C, and then it's Control Shift V, paste into a terminal on Raspberry Pi. Okay, and the last line. Do you want to continue? Yes. Okay, so this is going to take a few minutes. Yes, okay. And now I'm just going to reboot the Pi by typing sudo reboot. Okay, so the Raspberry Pi has booted up. I'm just going to get the instructions back again by opening up the browser. Going to the bookmark that I saved. All right, so we'd got up to here. Okay, so now we need to configure the Raspberry Pi. So I'm going to go to the Raspberry icon at the top, go to Preferences, Raspberry Pi Configuration, Interfaces, and I'm going to enable the camera, SSH, and VNC. So VNC is really useful. It's a kind of remote desktop service that's going to let us control the Raspberry Pi from my laptop later on when we don't have a monitor plugged in. Let's just say OK to that. So it requires us to reboot. Yes, let's reboot again. Okay, that's rebooted. Get the instructions again. So I'm going to need the IP address of my Raspberry Pi. So the way to do that is to open up a terminal and type ifconfig. And if you just look down this top one here where it says inet, and then there's a number 192.168.56.7. So that's my IP address. I'm just going to write that down, and I'm going to need that later. So another thing we need to do is to set the display resolution of the Raspberry Pi. And the reason that this is important is because later when we disconnect the display, it needs to know what resolution to start up as. So I'm going to type sudo raspi config. And I'm going to scroll down to advanced options and then scroll down to resolution.
Now, when you do this, if you click on press enter on resolution, you'll then get a list of options for screen resolutions. If you go down to the 1920 by 1080, then and select that, then that will be a good one for you. It's not working for me at the moment because I'm using a screen recording device and the Raspberry Pi is not letting me do it, but it will work for you. So I'm just going to go back. Something that I found when trying to get the VNC service working, which is the remote desktop system on the Raspberry Pi, is that it would only do very low resolution desktops when you had unplugged the monitor. And so there's an extra step I needed to do here to try and fix that. So I'm just going to do that now. And it's possible with later versions of the Raspberry OS, they may fix this problem and this step won't be necessary. But I know that it is necessary now. So we're going to do sudo nano boot config.txt. And I'm going to scroll down to where it says PI4. And these two lines here, we're just going to comment out with the hash symbol. Now, weirdly with the Pi, my keyboard never seems to manage to do a hash symbol. So I'm just going to copy and paste it from the instructions. So that was Control-C, then Control-Shift-V, and Control-Shift-V, and then Control-X to quit, and yes to save, and confirm the file name. And now we can reboot. So now we're going to go over to my laptop, which is a Mac. And let's bring up the instructions here. So github.com, Fetch.ai, car park agent. So here we're going to now just test out the VNC system to check that we can control the Raspberry Pi from the desktop. So if you don't have VNC Viewer installed, then you can install it from here. I'll just do that. Download VNC Viewer. Okay, drag it into the applications. Well, I've already got it installed. That's why it's asking me if I want to replace it. I'll just say yes. And then we're going to launch VNC Viewer. Yes, open it. Okay, so I have one here already because I've used this before, but I'm now in this address bar at the top. I'm going to type in the address of my Raspberry Pi, which is 192.168.56.7. Let's continue. So we now need to put in the username and password of our Pi. So Pi is the default username, and the password that we put in, if you remember, was ABC123. Okay, and so now we can see our Raspberry Pi desktop on my laptop, and we can interact with it as well. So we're just going to test that this actually works when the display is not plugged into the Raspberry Pi. So let's just close the Raspberry Pi down. So as I do this, obviously the connection gets dropped from the VNC Viewer. And I'm going to unplug the display from the Raspberry Pi. And then in order to get it to reboot, just need to unplug the power for a few seconds.
and then plug it back in again. And now just wait for it to boot up, and hopefully VNC Viewer will just reconnect. So the Raspberry Pi has now booted up. We can see its display on my laptop, and we can control it even though it doesn't have a display actually plugged into it. So that's great that that's working. So what I'm just going to do now is shut it down, plug the display back in, and then boot it up again. And while that's going on, there's a couple more things we need to do on the Mac. So let's just minimize that for the moment. Bring up the instructions. Okay, so the next thing we need to do on the laptop is get what's called an OEF node running. So the OEF node is a way for the Fetch.ai agents to search for each other and find each other and communicate. And eventually, this will be a decentralized network initially deployed by Fetch.ai. But because that isn't deployed yet, we need to run one of these nodes locally. So to do this, we need to bring up a terminal. And the instructions on the GitHub page are for a cleanly installed Mac. So they go through all the steps that you need to do. And I've done a lot of these previously in the past. I'm going to go through the steps anyway, so you can see what to do, but probably the output I get will be a bit different from yours because I've done it already. So let's install the Xcode tools, and it says they're already installed, so it's not letting me do it. And then we need to do this. To install Homebrew. And again, it's not letting me do it because it's already installed. Okay, and then we're going to do brew install Python 3 and OpenCV 3. Okay, and again, I've got this stuff installed already, so it's not letting me do it. And there's probably the same with virtual env. Okay. Okay, and now we need to get the car park agent code. So let's go to the desktop. And I'm just going to clone the GitHub repository into a folder on the desktop. And then navigate into it. Okay, so in order to run the OEF node, you're also going to need something called Docker. And there's a link to this in the instructions. Basically, if you go to the website, I'll show you where you can download it. You can install it here. Once you've installed it, you'll need to run it and sign into an account that you've created as well. And once you've done that, you'll get this little kind of whale icon. I think it's a whale up at the top here, which shows that the Docker daemon is now running. So now we should just be able to get this line here, paste it into the terminal, and this will launch an OEF node. Okay. And so if it says at the bottom, a thing of beauty is a joy forever, that means it's running correctly. So the other thing we're going to need is the IP address of my Mac. So let's go to System Preferences, network, and my IP address is here. I'm just going to write that down. So that's 192.168.56.54. Okay, and there are instructions for running this on a Windows laptop as well. There we go. So right, so now we're going to go back to the Raspberry Pi, which should have rebooted by now. But I forgot to actually reboot it, so let's just get it to do that. Okay, let's get the instructions up again. So I'm using a Raspberry Pi 4, so that's the instructions for this. There are also instructions for a Raspberry Pi 3. I'm going to open up a terminal, go to the desktop, clone the car parking agent code, and navigate to that directory. Okay, and then we need to get the data file that's required for the machine learning algorithms to actually detect cars. I'm just going to set that running. It takes a few minutes. Okay, and the next thing we need to install a whole load of stuff using apt-get. And that's this big long line in the instructions here. So you need to just scroll across to make sure you get everything. Very last one here is subversion. So Control C, Control V. Do you want to continue? Yes. Okay, so that's all finished installing. We're now going to install virtual env using pip. So we install virtual env. Now I'm going to create the virtual environment. And activate it. Okay, and now we install the car park agent together with all of its dependencies. Okay, good. So that's installed the software. So the next step is we have to build something called the autonomous economic agent. And to do that, I need to download these packages. Okay, so the packages are installed. And we now need to build this autonomous economic agent. And to do that, we use this thing called the AEA framework developed by Fetch.ai. And that will have been installed when we installed the car park agent. The first time I'm going to do AEA create car park AEA. So this creates an autonomous economic agent called car park AEA. I'm going to go into that directory and add the car park detection skill. Now we need to tell the agent where to find the Fetch.ai ledger, the blockchain that it's going to use for transactions. So to do that, I'm going to edit this AEA config YAML file. And I'm going to go to Ledger APIs, delete that line, and replace it with this text here. And exit, save yes to that file name. And we also need to tell our agent where our OEF node is. So the OEF node was the thing we got running on our Mac earlier that lets agents find each other. We go into the connections directory, edit this connection.yaml file. And then down here where it says address, this is the address of my Mac I need. So that was what we wrote down earlier, which was 192.168.56.54. Exit, save, yes. Okay, so let's just see if this runs correctly. Now we're just going to go back up to the root level directory and then into the car park AEA directory. Right, I just had to do a few things in my terminal window which you are not going to have to do. So my terminal looks a little bit different to yours, but the steps are still the same. So we have just updated the connection.yaml file. We've now navigated to the carpark_AEA directory, and I'm going to type AEA install. So this is just installing the dependencies which are specifically for this AEA agent. Okay, and we do get a little error here, but that's expected, saying error imgulg, I don't know how to pronounce it, blah, 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 requires OpenCV Python, which is not installed. It's all right, it is installed. It's a spurious error. We can ignore this. So now we should be able to just run it. So we do AEA space run. And it's starting up. Yes, so as you can see, it's all a bit upside down at the moment. So I'm just going to now attach the Raspberry Pi to the clamp arm. So just to test that all the computer vision side of it is working, if you have a look in the GitHub repository under resources, images, there's an image you can download and print out, which I'm just going to do and then show to the camera. Okay, and we can just see whether it detects the cars or not. Leave it a minute or so. Okay. Okay, so here on the top right, we can see the image that's been captured, and on the right here, we can see the cars that have been detected. If I just click down on that, we can see it in the image on the left as well. Good. Okay, so now what I'm going to do is disconnect the display, and I'm going to show you how to set things up. And we're going to use VNC Viewer from now on to control the Raspberry Pi. So the Raspberry Pi has booted up. Now, normally, we'd have the Raspberry Pi looking out of the window at places where cars can park. But just for the purposes of making this video, it's a bit easier to just use some of these boards with
pictures on. So that's what I'm going to do here. But you should have yours now pointing out of the window and controlling it via VNC Viewer from your laptop. So I'm going to open up a terminal. I'm now going to navigate to the car park agent directory, activate the virtual environment. So source and bin activate. Then navigate into the car park AEA directory and do AEA run. And let's just get the instructions up again so I can remember what I'm doing. So we can now see the view that the car park agent is seeing. The big view on the left here is the camera looking at one of these boards. Now, what we need to do is identify an area that we are interested in reporting on. And I'm going to choose this area here, which currently doesn't have any cars parked in it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces here. And I'm going to say edit detection area, capture reference image. And so this allows us to specify which areas we're going to be detecting cars in. So the blue is detection. So I'm going to fill all with red. I'm going to click on draw detectable, and then I'm going to draw an area. Go, and then we can flood fill. And we said that there were 9 spaces here. So up here where it says max capacity, just going to click the right arrow to put that up to 9. And we go back to live detect. Okay, so now if we just wait for a detection to take place. So on the Raspberry Pi, it takes about a minute to perform the detections, and I think it's set up to do them once every 2 minutes. Okay, so it's now done a detection in the area which I identified. And we can look over here, it says vehicle count 0. So it hasn't detected any vehicles, which means the number of free spaces is 9. So if we now just get one of the other boards, I'll just wait for this again. Okay, so now we can see it's detected the car in the new image here, and vehicle count is 1, so obviously now there are 8 free spaces. So obviously if we had this one, you would hope it would detect 3 cars and there would be 6 spaces and so on. I'm just going to quit out of this at the moment, just get a few final things set up on here. So we need to tell the agent where we are in the world, so it knows where the car parking spaces are. So to do this, I'm going to open up Google Maps. So our offices are actually at the St. John's Innovation Centre in Cambridge. Okay, that's just here. So I'm just going to right click, say what's here. And that's now got the longitude and latitude of my location. So I'm just going to copy that, select it, copy. Okay, and I'm just going to Control C out of this. Okay, so we need to put the longitude and latitude in. So I'm going to do CD skills, car park detection, nano skills.yaml. Sorry, nano skill.yaml. And here we can see the latitude and longitude, the default one. I can't remember where that is, but I'm just going to paste in my longitude and latitude. So I'll just paste it in twice, one there, one there. And the first number is the latitude. Second number is the longitude. So now we can close that down, save, yes. So the final thing is that we want the agent to start up automatically when the car park agent boots. So in order to do this, I'm going to create a cron job. So in the terminal, I'm going to type cron tab -e. I have to select an editor, so I'll say 1 for nano. I'm going to scroll right down to the bottom, and I'm going to paste in this line here. So this is just a bash script that I made, which basically goes to the correct directory, activates the virtual environment, and then calls AEA run. Let's see. V, and then Control X to create, save, yes, there. And now I'm just going to type reboot. So now when the Raspberry Pi boots up, we'll see it on the VNC remote desktop, and it should start up the agent automatically. Okay, here we go. Okay, so actually the GPS location that it says down here won't update until it's done another detection on the car park, but that will update eventually. So now we're going to go onto the laptop and set up a client agent that is going to buy this car parking space data from the Raspberry Pi. Okay, so on my Mac, I've still got this terminal with the OEF node running here. Let's bring up the web browser with the instructions. Okay, here we go. So installing the client software on a Mac. So we've already done some of this when we got the OEF node up and running, so there's not so much to do now. I'm going to start up a new terminal window. And let's just minimize that. I'm going to navigate to the car park agent directory because we already downloaded the code. I'm going to set up a virtual environment. We haven't done that yet on the Mac. I'm going to activate it. Okay. And then I'm going to install all the stuff. And then, as before, we're going to use the Autonomous Economic Agents framework. So I just need to download this packages directory as well. Okay, so the packages are installed. We're now going to create, using AEA, we're going to create the client agent. So create agent, I'm going to navigate to that directory, do AEA add skill car park client. We again need to point it at the ledger. Save that. So we don't actually need to set up the OEF, pointing it to the OEF node, because it assumes it's just running locally at the moment. So we're now just going to do AEA run. See what happens. Oops, sorry, I forgot a step. I've got to do AEA install. And now I can do AEA run. Okay, so this is running. However, what you'll notice is the very first line, it says you have no starting balance on your Fetch.ai ledger. So basically we don't have any money on this client agent, so it can't pay for any information. So let's just Control-C that. We're going to give it some money. So we go upper directory, and I'm just going to run this thing here, which calls a script, which is just going to give some money, generate some FET tokens for my agent. So this obviously won't be available when our mainnet goes live. So the test ledger allows us to create these agents talking to each other and transferring wealth. The only real difference is, firstly, that it's possible to just generate FET tokens out of nowhere, which obviously won't be possible when we move to mainnet. And the other thing is it's running a lot slower, so it takes about 30 seconds to complete a transaction or generate any wealth, whereas eventually this will be much, much faster. Okay, so we've generated some tokens now for our agent, and we can again do AEA run. I'm not in the right directory, so we go to car park, client agent, AEA run. Okay, so this agent has started up. It's sent a search out saying what agents are there that can report on car parking spaces. Our agent has responded. This client then says, right, send what's called a CFP, which is a call for proposals, to say, what can you propose to me? And our agent has then said, well, here I am, here's my longitude and latitude. I can report on 9 spaces. And it's got the price here, which is basically looks like a big number, but it's a tiny amount. It's a fraction of a pence. And our client has said, okay, I accept that proposal. And it then sends that transaction off to the ledger. And well, it then waited a while I was talking for that transaction to be verified. And that transaction was successful. And so it's now received the information of interest, which is that there are 6 free spaces in the location that it covers. And we can just go back to our VNC thing. So yes, so this is what the car park agent is looking at now, and you can see, yes, there are indeed 6 free spaces. If we look in the top left-hand corner, this shows the current balance of this agent, how much money it has effectively. And so each time our client requests data and pays for it, this number will go up. Okay, so I've shown setting up the car park agent, detecting car parking spaces. It connects up to our blockchain ledger and the OEF node, which allows other agents to find it. And then on the laptop, we've got the client agent, which can search for car parking agents and then pay them for information about how many free spaces that there are. Well, that's all of it. I hope you managed to follow along okay. If you do have a go at this yourself, do let us know. You can contact us on info@Fetch.ai. We'd love to hear about it, and we'll send you a free t-shirt as well. If you have any problems, you can contact us on developer@Fetch.ai. And if you're interested in learning more about agents, you can check out some of these videos over here.